All right. Beautiful Sunday evening to everyone. Happy Sunday to everyone. I hope you enjoyed a good time in church today. So I'm sure I'm audible at this point. Hope everyone can hear me properly. So as promised, we're supposed to exhaust every other question in the past question we're solving. I believe we have solved about 20 out of 30 questions. So we're hoping we solve the rest of the questions in this particular class. All right. So please get your writing materials because I would love you to take notes of everything I'll be saying. We'll be solving some questions around calculus today, and I'm hoping we can do justice to all your challenges in calculus as much as we can today. So the very first question we'll be solving will be the polynomial question in the past question. If you have your question there, you can look through on what we're doing. So the first question said, determine the respective values of P and Q if x minus 1, x minus 1, and x plus 2 are factors of this particular polynomial. So look at the question. This is something we did, I believe, last year while I was explaining polynomials to you guys. We have what we call the factor theorem. And under the factor theorem in polynomial, the factor theorem states that if x minus c is said to be a factor of a polynomial, then that means when you fix in x equals to c into the polynomial, you must get 0 as the answer. Let me repeat that. Factor theorem states that if x minus c is a factor of a polynomial, when you fix in x equals to c into the polynomial, you should get 0 as your answer. So one way to know that something is a factor of a polynomial is that imputing the value of that thing into the polynomial will give you a value of 0. That means if they told us that x minus 1 is a factor of this polynomial, so we are told now that x minus 1 is a factor of this polynomial. That means if I put in x equals to 1 into this polynomial, I must get my answer to be 0. That is the theory around factors in polynomial. The same thing goes for the other factor here. We are told that x plus 2 is a factor. That means if I put in this case, x equals to minus 2, you can look at, the general law states that x minus c. That means in the case where you had x plus 2, what you'll be fixing in will be minus 2. So if I fix x equals to minus 2 into this polynomial, I must get my answer to be 0. It's a theory under polynomial. So looking at this theory, using that theory to evaluate this particular question now, look at what we're going to get. Now that we've been told that x minus 1 is a factor of this, that means let's call this polynomial px. let's just call it px. That means p1, that's when x was equals to 1, will be equals to 2. I'm fixing 1 into the polynomial now, plus p, I'm fixing 1. Wherever I see x, I'm fixing the value of 1, minus 1 plus q. This must give me 0. If it doesn't give me 0, that means it's not a factor. So the fact that they've told me that it's a factor means that by fixing that value inside the polynomial, I must get 0 as my answer. All right. So let's try and solve this question, this particular expression. This is 1 cubed. That will be 1. This will give me 2 plus 1 raised to power 1. Sorry, this was supposed to be raised to power 2. So 1 raised to power 2 is also 1. That will be plus p. This is minus 1 plus q equals to 0. All right. This is collecting like terms. This is 2 minus 1. That will be 1 plus p plus q equals to 0. Of course, we want to fix in all the like terms, the variables in one side and fix the constant at the other side. So I will have p plus q equals to minus 1. All right. So I'm going to put this somewhere. I'm going to put this right here. Let me put this here because I'll be rubbing this off. So let me just put what we got here. P plus q equals to minus 1 was the first expression we got when we fixed in 1 into the polynomial. Now let's go on to solve for when we fixed in the second factor. That's the case for when we fixed in minus 2. So p minus 2 will obviously we'll be fixing wherever we see x now, we're fixing minus 2. That will be 2 minus 2 raised to the power of 3 plus p minus 2 raised to the power of 2 minus 1. Sorry, minus, this is, we have x here, so this will be minus 2 plus q. Now, because it's a factor, all this must give me the value of 0. So that's just what we're doing. We're fixing the value of minus 2 into our polynomials. And by fixing, since they told me that x plus 2 is a factor, fixing x equals to minus 2 must give me 0 as my answer. All right. So if you go on to try and solve this, trying to solve this now, you'll be having minus 2 raised to the power 3 will give me minus 8. That'll be minus 8 times 2. This will give me minus 16. I'm sure you can follow that. Minus 2 raised to the power 2 will give me 4. 4 times p, that will be plus 4p. Then this will be minus times minus, this will be plus 2. And this will be plus q. Must give me a value of 0. All right. So we try to solve the constant. Minus 16 plus 2 will give me minus 14. And we have plus 4p plus q equals to 0. All right. Now looking at this, you can see that I can group this as 4p plus q equals to 14. All right. Now this is my second expression, which I got when I fixed in the value of x equals to 2. Now, I want to put both of them together now. I have 4p plus q equals to 14. Now, I'm sure you guys can realize, what is this equation called, this kind of equation called in mathematics? What do we call what I have right here? What do I call this entire, what I have here? What do I call it in mathematics? Anybody with an answer to that? Well, this is called simultaneous equation. And what I just have to do is to solve it simultaneously. And to solve this simultaneously, I can go on to use the elimination method, where I want to eliminate the q, because I can see we have Q and Q here. So what I have to do is to just subtract the two equations. So by subtracting, what I'm going to have is P minus 4P. So I will have P minus 4P. That will give me my value of minus 3P. Q minus Q, that goes away, that will turn to 0. Then I have this other side, minus 1 minus 14. That will give me minus 15. So obviously, I divide both sides by minus 3. And I have P equals to 5. Don't forget, we were told to find the value of P and Q. So I've successfully gotten the value for P. All right. Now, how do I get the value of Q? Very easy. The only thing I need to do next is to fix in. You can go through any other method, by the way. You can go on to try to still use simultaneous, but I don't need to do all those. What I want to just do is to fix in the value of P equals to 5 into any of my equation. So I will try and fix P equals to 5 into the first equation. So if I have, my first equation was P plus Q equals to minus 1. If I fix in P equals to 5 there, that will be 5 plus Q equals to minus 1. This will be Q equals to minus 1 minus 5. This will be Q equals to minus 6. So we have successfully solved this question on polynomial. Once again, the question said we should find the value for P and Q. The value for P is 5 and the value for Q is minus 6. All right, let's move straight into the next question. The next question is quite simple. But let's just do it because this is a general class. So we'll be solving some questions very soon on calculus. Please don't forget to take good notes. Very, very important. So the next question said we are supposed to solve. The next question is based on composite function. We have a function given and we have x squared plus c, and we have another function given g ax plus b. We have to find g o f x. So here is the question. This is quite simple. I believe everybody should be able to solve this. Can you give an attempt to this quickly in like 2 seconds? Okay. Now looking at this is composite function. I think I explained this in possibly our first class. When you have a question like this, what you just have to do is understand that the very first alphabet written is the parent, while the other alphabet is the child. So in this case, now your parent function is your G and your child is the F. So what you want to do now is to embed the child inside the parent. So you have to use the parent as the main function. So this was the parent function, ax plus b. This was the parent function, the G function, ax plus b. So when you want to solve a question like this, you want to embed the child, that's f, inside wherever you saw x in the parent function. This is the only place where we can see x. So instead of writing x now, we want to fix in the child function. That will be x squared plus c. So it's just as simple as that. So we want to open this now. We'll be having ax squared plus ac plus b. All right. So this is just the way you solve questions of this form. All you have to do is just embed the child inside the parent. So I believe that one was clear. We don't have to do much on that. Let's go to the next question. Please, I hope I'm not too fast for anybody there. Are you following? Okay, so the next question is a question on limits. I'm thinking I should solve some other questions and come last. I should come at the end of the class on this. So let me try and solve question number 4. I'll come back to question number 3. Question number 3, I'll come back to it. Question number 4 is a question on inequality, absolute value and inequality. Very cheap, and I expect everyone should be able to solve this. All right, please pay attention. Look at the question. We have 2x minus 3 greater than 5. The question said, obtain the range of values for which the absolute value for 2x minus 3 is greater than 5. All right, so this is something very simple, although I would love to give as much clarity as I can so that everyone can get the best. Now, looking at this question, one thing you need to understand about absolute values is that absolute values always have two different possible answers. And this will be on the basis of the fact that you understand the rule around absolute value. Under absolute value, if I wrote 2 here, I want you to understand that it's possible that I could have, of course, this will give me my answer as 2. So it could also be minus 2, because minus 2 will also give me 2 under absolute value. So this implies that when we have a question like this, we have this particular input here, 2x minus 3, can take 2 different values. We can have it as the just positive 2x minus 3, which will still be correct. And we can also have it as the negative 2x minus 3. I don't know if you can follow what I'm saying right here. We have, looking at what I told you here, if you had 2 inside here, 2 and minus 2 will always produce the same thing. So in a case like this, when you have 2x minus 3, this and this are both outputs that could be from this. So it's possible for you to have minus 2x minus 3 and it will still be fine, because absolute values will always cancel out the negative sign. So that means these are 2 possible values to have. Now, you have to make use of, don't forget, the question wants you to find the range of values for which this is greater than 5. So what you have to do is to ensure you exhaust all the possible values. You cannot just solve for this alone, this particular first one. Solving for this particular first one alone will mean you are omitting another possibility, which is also this. So all you have to do is to bring out all the possibilities, which is the 2 different versions I've written, this and this. So you have to solve this, both of them, using the inequality. So you solve for when 2x minus 3 is greater than 5, and you solve for when this is greater than 5. All right. Now, in solving for this, let's try and solve for the first. 2x minus 3 greater than 5. If you have this under inequality, what happens right here is you want to either decide to add 3 to both sides, because this inequality, you have to, you treat it almost like you're treating the equals to, depending on the sign anyway, and depending on the operation you are dealing with. If you're dealing with negative sign with multiplication and division, there are some things that happens. But in this case, we won't deal with addition. So if we decide to add 3 here to both sides, we can easily just cancel this out. So we have 2x greater than 8. You can also decide to say you want to shift this to the other side. That means we'll be having 2x greater than 5 plus 3, Whichever way is still very much fine. Now, what you have here, you can go on to divide through by 2. So you have divided by 2, divided by 2. Now you notice that you are dividing by a positive number. So in this case, the direction of the inequality remains the same. But if you had to divide through by negative number, the direction of the inequality would have to change. So in this case now, since we are dividing through with a positive number, we will be having x greater than 4 as our final answer. All right. Now this is for the very first one. Let's solve for the other possibility we have here. This one right here. That's minus 2x minus 3 greater than 5. Looking at this, we have minus times 2x, that will be minus 2x, minus times plus minus 3, that will be plus 3 greater than 5. This is the other possibility when you are dealing with absolute value, as I explained earlier. So looking at this, you want to also solve this the same way. Minus 2x, you can decide to subtract 3 from both sides, or you can decide to move 3 to the other side. Whichever one will work fine. So this will give me greater than 5 minus 3. That will be 2. All right. Now look at this example. We are having a situation where the division here will have to be, because if you are trying to find x, you have to divide through with the coefficient of x. The coefficient of x here is minus 2. That will absolutely change the direction of your inequality. So if you want to divide through by minus 2 now, you cannot have your greater than remaining as greater than. It has to change. I told you already, when you're dealing with multiplication and division, and you are dealing with a negative value, your inequality will obviously change in the direction. So in this case now, we'll be having minus 2x over minus 2, no longer going to be greater than, now less than 2 over minus 2. All right. So what we have here will give me x less than 2 over minus 2 will give me minus 1. So looking at this now, the question said we should obtain the values, the range of values for which we are supposed to obtain the range of values for which this happened. And because we're dealing with an absolute value here, that was what made us to have two different options, because these two different options are valid with the absolute value. And that was why we went on to do for the first scenario, and we did for the second scenario. This was for the first scenario, we got x greater than 4. This was for the second scenario, we got x less than minus 1. So these two are the values we are going to have when dealing with this particular expression. So this is the answer, x greater than, the range of values is x greater than 4 and x less than minus 1. Now you can go on to write it this way, just to bring it together, because when x is less than minus 1, that means minus 1 is greater than 4. I'm sure you understand what I just said. If x is less than minus 1, if x is less than minus 1, that means minus 1 is greater than x. For instance, what values do we feel, just for you to understand better, what value do you feel is less than minus 1? Minus 3, of course, is less than minus 1, for instance. Of course, you agree with me that minus 1 is greater than minus 3. So using this fact, we can rewrite this x less than minus 1 as minus 1 greater than x. Of course. And we were also told here that x is still also greater than 4. So we can fix it also here, just to bring both of them into one full inequality. All right. So this is the answer to question number 4. We can move on to the next question. I'm sure I'm not too fast. Okay, let's go to the next question. All right, let me try and solve another question. That's question number 8. still on inequality so that we can move and flow in the same vein. Now, we have another question in question number 8 that has to do with inequality also. So I would probably give you the opportunity to make an attempt, just giving you like about 2 minutes, and then I will give you the solution so that you could use whatever knowledge you just learned. You can apply it in this next question. Now look at the question that you were given in question number 8. You are to solve for the values of x if 2x minus 3 is equals to 7. You have to solve for the value of x if 2x minus 3 is equals to 7. All right, let's give just 2 minutes. Okay, it looks like somebody is asking for me to explain. Well, I would use this other question to explain if you still have an issue with it, but let me get good responses from people that had understood what. Let me get great answers from people that followed through on what I just explained. What do you feel this answer will be? You are supposed to find the values for x if this happens. All right, I've gotten 2 answers. Okay, let me hear from other people based on what I just told you. Okay, now I love what I'm seeing. I love what I'm seeing. Is there no sign? This is the question. That's just the question. Okay, I love what I'm seeing. That means you guys are following. All right, now look at what we have here, just to put more light on it for those of you that could not follow initially. We have a question like this. We're told to find the values for x. Now, because you have this absolute value, that's key. I told you, absolute values will always bring out 2 different possibilities. Now, one of the first possibility here will be the one where you just have 2x minus 3. And then you will also have a situation where you have 2x minus 3. These 2 things will stay inside this absolute value and produce the same answer, because absolute values will always delete the negative sign. So these 2 are great possibilities that could come out. Now, don't forget we have the equation as this. So you just fix this there and you solve for these 2 possibilities. So the first possibility is 2x minus 3 equals to 7. 2x obviously will be equals to 7 plus 3. 2x will be equals to 10. X here will be equals to 5. That's the first answer. All right. The second one we have minus 2x minus 3. Always use your bracket carefully. In this case, you open the bracket, we have minus 2x plus 3 equals to 7. And this will be minus 2x equals to 7 minus 3. This will be minus 2x equals to 4. And this will be x equals to 4 over minus 2, which will be given as minus 2. So can you guys see that this is quite very easy? So I don't expect you to miss any question when it comes to inequality again. All right, so let's try and move on to something else. I believe I'm not too fast for anybody. Hope I'm moving at the right pace. Hope you guys are flowing. Okay, so let's solve. Okay, let me solve question number 9. That's just a very easy question. Let me solve question number 9. Question number 9 gave you something like this, and you're told to talk about the properties. You're told that A and E are elements of real numbers. Then you were told that then this operation happened. A binary operation E was equals to E star A, and all this produced A. So you were asked to discuss the property that was going on here. Now, what property is this related to when dealing with binary operation? All right. So some of you felt this was commutative property because you saw the very first two expressions, this and this, made many people feel this was commutative property. Now, if they stopped this here, if they wrote this as A star E equals to E star A, if they just wrote this, this will be the perfect definition of commutative property. But they went on to tell you that at the end of all these things, you still got your element back, your A back. This is the definition of what we call identity property. Identity. Under binary operation, and this is also very much under matrix also. So it's not only in binary operation that you have identity property. Identity property is that thing, as I do tell you guys, it's more like a mirror. It's more like when you bring an identity element, this E here represents the identity element. If you take an identity element with any other element, it will always produce the element back. So for instance, if you take P with the identity property E, it will always produce back P. So when you see anything that has to do with something like this, that you had two elements coming together and you were getting this back, that means this particular E is the identity element. So the question could come and say, what is the element E? If they ask you to identify the element E, this element E is the identity element. So it's like a mirror where it brings back the element you used it with. All right. So that's that about that. Now let's go to the next question. Okay, I can see a question here that said resolve into partial fraction. That's question number 10. Question number 10, we're to resolve into partial fraction. So I'm sure you guys are not having issues with partial fraction. So I'm expecting that you should be able to resolve this easily. We have x over 1 minus x squared. A very simple question right here. You're supposed to resolve this into partial fraction. Now, guys, if you are on this feed, if you are in this live stream, and you are yet to give a thumbs up to this video, check it out quickly. All right. We have over 60 people on this feed, and we have just 29 thumbs up. All right. Now we're dealing with partial fraction. There are many different possibilities on that partial fraction. But for this particular one, we have quite a very simple, basic expression. All right. Now, look at this question. If you're not very used to algebra, you may be having some issues in seeing what's going on here. When you see something like this, you should be able to notice something happening under this at the denominator in this particular expression. Something is going on here that makes your work very easy if you're able to recognize it. It's something in algebra called difference of two squares. Difference of two squares. It's something where you have 1 square minus x squared. And when you have 1 square minus x squared, under algebra, we always have the expression rewritten as 1 plus x and 1 minus x. That's the basics of algebra. When you have difference of two squared, that means in the case where, for instance, let's say you had a square minus b square, this will be given as a plus b, a minus b. If you had figures, let's say you had 16 minus 9. Of course, this is 4 square minus 3 square. This will obviously be 4 plus 3 and 4 minus 3. So this is just a particular topic under algebra. So when you see a question like this, what you just have to do is you have to change the denominator to reflect difference of two squares. So that's the first step. All right, so that's the very first thing you have to do. So now that you have done that, what's the next thing? For you to resolve this into partial fraction, you want to split your fraction, which I'm sure you are very familiar with if you have been studying partial fraction. That means you want to have this now as a over 1 plus x partial fraction. This is one of the fraction. And b, this is a very simple partial fraction, so it doesn't have the bx plus c or whatever. It's just very simple and basic. So now we have x over 1 minus x squared given as this. So for us to complete our partial fraction, we have to find the values for a and b. That's the next thing to do. All right. Now, what do you want to do next? You want to find a way to eliminate. Let me write. This was what I was supposed to write here, so that because we have already resolved that one into partial fraction, so we have, into difference of two squares, so we have 1 minus x. The next thing to do here is you want to find a way to bring all this, remove the entire denominator here. So you don't want to have all these many denominators. You want to bring all this into just a single expression. And the best way to do that is to multiply both sides. That means this particular left-hand side and this right-hand side. You want to multiply through by, you want to use multiply through with 1 plus x and 1 minus x. So this is what you want to do to both sides. That means in this particular one now, you have times 1 plus x times 1 minus x. And then you want to do that for each of these. This will be times 1 plus x, 1 minus x. Don't mind the space, please. I'm sure you understand what we're doing. I'm just trying to manage the entire board. We have times 1 plus x and 1 minus x. So you want to do that on, in mathematics, you have to do whatever you do to one side, you do to every other side. So what's going to happen here is that this whole thing will cancel. Of course, all this will cancel all this. This will cancel this. You'll be left with 1 minus x. And the 1 minus x here will cancel this. So what you'll be left with will be x equals to a into bracket 1 minus x plus b into bracket 1 plus x. So this is what we're going to arrive at after doing what we were supposed to do. All right. Now, this makes it all simple. Once you're able to get to this particular place, that's all. The only thing you need to do is to just do some basic things and you will be arriving at your final answer. So look at what we have here. Don't forget the values of interest is a and b, because those are the two things I'm looking for to make my partial fraction completed. So I have a here, I have b here. You can decide whichever one you want to find first. If I want to find b first, I will go on to fix the value of x as 1. The reason this is one technique in partial fraction where you want to eliminate a particular value first. So if I go on to fixing my x as 1, I will be able to successfully take out A. And if I'm able to successfully take out A, I'll be able to find the value of B. So I have 1 minus x. So I go on to fix it. Imagine I had 3 here, 3 minus x, and I wanted to eliminate A. I'll be fixing x as 3 because 3 minus 3 will be 0, and 0 times A will be 0. So I'll be able to successfully eliminate that. So in this case, we have 1 minus x. So I want to successfully eliminate A by fixing x as 1. All right. So what will happen if I do that will be put x as 1, put x equals to 1. I will have 1 equals to, all this will go, but in case you need to see it go, let me just fix it there for those of you that need to see it. 1 plus 1. I fixed x as 1. All right. So what we have here is 1 equals to this. 1 minus 1 is 0. This goes away. I'll be left with 2 because 1 plus 1 is 2 times b, 2b. From here, you can see that your b is equals to what? 1 over 2. So I've been able to successfully get my b value. Now, that's for b. If I wanted to find for a, what do I need to do? Still come back to this expression. This particular one, the original expression, this expression right here. Come back to this expression. Now ask yourself, if I want to find b, that means I want to eliminate a. So if I want to find a, I want to eliminate b. I found b, I want to find a now. So I want to find a. What do I need to fix x as that would be able to extinguish b, and I'll be able to find a? Look at this side here. This is 1 plus x. If I fix x as minus 1, that will turn to 1 minus 1, and that will be equals to 0, and that will mean my b will have to automatically go. So what I have to do next is I will put x as minus 1. So what I will be having will be minus 1. That was the first thing. X is equals to a into 1 minus minus 1 plus this will turn to 0. I don't think I need to write that, but if you want to see it to be b, and then this will turn to 0. So this will go. So I'll be left with minus 1 equals to a into bracket 1 minus minus 1. That will be 1 plus 1. That will be 2. In this case now, you can see 2a equals to minus 1. A is equals to minus 1 over 2. All right. So I have gotten my values for A. I have gotten my value for B, which was the most important thing I needed to find to complete my partial fraction. So all I need to do now is to go back to my original equation. That means I want to come back to this original equation where I had A. Okay, let me use this particular one on top here. So I want to go on to rewrite the equation now. Instead of putting A now, I'll be putting the values for A. That means I'll be having minus 1 over 2 all over 1 plus x plus b is 1 over 2. 1 over 2 all over 1 minus x. All right. So this is exactly the final answer, but you can obviously make this much more mathematical where you have to bring those values down. So you'll be having it as, you can finalize by writing it as equals to minus 1 over 2 into 1 plus x plus 1 over 2 into 1 minus x. And this will be your final answer for your partial fraction. All right. This is how simple it is. All these things are very simple. You just need to have the basics. Once you understand the basics, you can't go wrong. All right. So let's see some other questions. I think we can move to the questions on calculus limits now. I think we have solved basically every other question apart from the questions on limits. So let's start with the very first question on limits. Okay, somebody is asking if I arrange it as 1 minus x and it will still give you the same thing. It will just be about rearrangement, that's all. It will still be the same answers. Try it. You can try it. You don't need to be whatever you do, you will still get the same thing. Write your final answer and check it out. If it doesn't, it's still going to come back here. It's still going to come back to this equation. You can try it. It's still going to give you the same equation. That A and B are just dummies, more like placeholders. So at the end of everything, you will still get the same thing. So let's get into limits of functions. That's under calculus. This, I would love to see a very tangible note from everyone tomorrow. Please don't hesitate to bring your notes. I would love to see all the jottings from the weekend's class so that we can be on the same page, all right? All right, now look at this question number 5. It's on limits of a function. We have the limit of x tending to minus infinity, and we have 5x squared minus x plus 2 divided by 4x cubed minus 4. So this was the question. You're supposed to determine this. You're supposed to determine the final outcome of this. So let's see how this goes. What do we do first? Of course, understanding limits is something you need to really be conversant with. And one thing you can see right here is we're dealing with a situation where our limit is tending to infinity. Now, if this was probably tending to, say for instance, 3 or 1, then you want, let's say this was tending to 1, then you want to fix 1 inside this and get your answer. But this is tending to infinity. And if you go on to fixing infinity as your hex values, what you're going to get is not going to make much sense. It's more like having 5 infinity minus infinity square minus infinity plus 2. Everything will just give you 4, let's say minus infinity cube minus 4. Everything will be giving you, because once you have infinity in questions like this, infinity is going to always produce infinity. So you'll be having like almost like saying infinity over infinity or something like that. So you will not be arriving at something tangible. So what you want to do in cases like this is to divide. You want to first work on this expression within the bracket. And what you want to do there is you want to divide through you want to divide every of the elements in this expression by the highest power. So your variable with the highest power, you want to use to divide through. What I mean by what I'm trying to say is you want to do something like this first. The highest power is x cubed. So you want to say 5x squared over x cubed minus x over x cubed plus 2 over x cubed over 4x cubed over x cubed minus 4 over x cubed. This is the first thing you want to do, all right? So when you're done with this, you'll be getting, this will be giving you 5 over x minus 1 over x squared plus 2 over x cubed over 4 minus 4 over x cubed. All right. So this is what you are going to first do when you have a question like this, when you are having a situation where it's tending towards infinity. So at this instance, you want to go on to now fix in your values of x, which is tending to negative infinity. All right. So you know what I'm doing here? I'm trying to just, because of the space. So you're fixing your x as the negative infinity. Now, what's going to be your result here? What's going to be your result? When you have 5 over negative infinity, what that will give you is 0. 1 over this will give you 0 also. This will give you 0 also. When you have something over infinity, it's always producing 0. And this will be over 4, because this doesn't have anything. This will be 4 minus. This will also produce 0. So you're having 0 minus 0 plus 0. Now, all this will be 0 over 4 in the end. And what's 0 over 4? 0. That's your final answer, 0. All right. So that's that about that. I hope everybody could follow what I said. Hope nobody was confused. Hope you understood what I did. And I get good feedback. Were you able to follow? Because I want to move to the next question. I want to be sure that you understood what I just did. So the whole step is, when you have a question like this, because I wrote this right here, you don't want to be fixing your infinity into the expression directly. That will be giving you infinity over infinity, which will not make much sense. So what you want to do is to first divide through by the highest power. So when you check through everywhere, you can see x squared is here, x is here, x cube is here. Of course, x cube is that with the highest power. So you want to divide through by x cube, each of the elements in the expression. So you go on to divide through by x cube, and then you are able to come up with something like this. Then you fix in your infinity in that instance. Now, if you look at this, will produce 0, this will produce 0, this will produce 0, this will be 4 minus. Now, imagine the reason why you do something like this. That imagine, for instance, we had like a 4 or maybe like a 8. Let's say this was 8. Now, let's say this did not have infinity around it. Let's say this was 8. And all these are still the same. You would have had a result like 8 minus 0 or plus 0. Then that would be 8 over 4. You see that in that case, you would have gotten 2 as the answer. So that's why you want to first do this good housekeeping by dividing through by the highest power. So that's the first step you need to do, and then you will go on to fixing your infinity. So let's try and solve the next question. I think after this, we probably will have just one more question. Yes. Somebody said, n number divided by infinity is 0. Yes. You are not wrong. It looks like you guys are learning a lot. That's nice. That's impressive. I love that you're following. The exam is coming soon. I'm expecting the best this time around. All right, this was the question. This question, okay, you have to evaluate limit of, we have x tending towards, okay, and then we have, okay, we have absolute value here again. There's so much about absolute value in this here. Is this O2? I'm guessing this is O2, right? Is this O2 or O1? I think it's O2. You have so much of absolute value present. So you have to really understand that concept around absolute value, because it seems like a very pivotal aspect. Okay, so we have a question on limits here, but this one involves absolute value. Okay. So how do we solve a question like this? So hopefully we have some times to deal with calculus as a whole. I'm hoping we can talk about that and see how we can organize that. So, so that we can, because this is just resolving questions, so we'll be able to solve this. We can go into the details of this and establish the basis around all this. So hopefully we can have that class probably later. All right. So, but because of we're just trying to solve the corrections of this particular test. Let me just try and solve this for you. Now, when you see, let's start from the absolute values again, because when you see this absolute value, just remember one thing. You're seeing absolute value of 3 minus x. Just know that two things can come out from this. The first is we can have 3 minus x, and then we can have minus 3 minus x. Just remember that. The same way, I believe we have done this in the previous, probably the starting of all this. And of course, this is happening when if our is obviously greater than or equals to 0. And in this case, if our, I will explain this very soon, don't worry, just hold on. So now, just these two things I said is what we've talked about before. Like for instance, if you have x minus 5, of course, this is stemming from two different possibilities. We can have x minus 5, and we can have minus x minus 5. Now, this x minus 5 is obviously when we are saying this particular thing is greater than 0. That means within is greater. In this case, x minus 5 is greater than or equals to 0. That's a case where this means just means it's a positive number. But in this case, that means x minus 5 wasn't a positive number, it's less than 0. All right. So I'm sure you follow that. So this is a case where when whatever is within this absolute value is a positive number or 0, that's when we have it as just x minus 5. No negative sign is there. But when negative sign comes into anything, that means that thing was less than 0. This is just basic mathematics. So if I have minus 5 is obviously less than 0. If I have minus 9, it's obviously less than 0. So just so you identify with these things so that you can easily relate to it when we are trying to solve this question. So when I have 3 minus x in absolute values, I can produce either 3 minus x with a positive sign or 3 minus x with a negative sign. And the first one will be when, of course, will indicate that was greater than or equals to 0. This other one will indicate that this thing was 3 minus x was obviously less than 0. That's just basic. Now, having understood that, let's try and now talk about this, what we have here, this 3 plus. So if you say x tends to 3 plus, what that implies is that we say that x is greater than, it moves from 3 upward. All right, it's greater than 3. Now, if you say x is moving towards, this is not part of the question, but let's just act like we wanted to solve that for 3 minus. If you're dealing with 3 minus, in that case, x is less than 3. All right. Does it make sense? Am I still communicating with anybody there? Okay, are you still following me? Okay, so I'm hoping, sorry, it looks like the chat has gone out. Okay, some people are following, some people are not following. Which part are you not following? Let's move on together. These two things, again, I don't want to say so much around this, but when you see something like this, this is what's going on. This when you say x tending towards 3 plus, this is the implication. And when you say x tending towards 3 minus, this is the implication. Just note that probably when we get into calculus, we would try to explain more on this. All right, is that perfect? Just know these two things. Now, this one I did here, I hope this was not what was confusing you guys. If I said I said something, if we say 3 minus x, if we say 3 minus x on with absolute value, I'm sure you guys agree with me that with what we did before, we can have 3 minus x, of course, with a positive sign. We can also have 3 minus x with a negative sign. We did this already. These are the two possibilities when you're dealing with absolute value. This is all coming up because of the absolute value. All right. Now, just note that now I've tried to settle this absolute values part by writing this here. I want to settle this other thing. I want to pick this whole thing one bit at a time. So this is the possibilities when you have the absolute value of 3 minus x, what we have here. And when we have x tending towards 3 plus, the implication of this is what I wrote here. I now said, in any case, probably if you have it tending towards 3 minus, this is the implication also. Just note that, then let's try and solve now. Now, if you have 3 minus x, now pay attention. Let me remove this negative part because that's not what we're dealing with here. We're dealing with the positive scenario. So now we have 3 minus x. Look at what is our subject here, 3 minus x. 3 minus x. Please pay attention to this. 3 minus x. Please, I want you to give me my answer now. If x is greater than 3, I want you to tell me, will 3 minus x be greater than 0 or less than 0? If x is greater than 3, I told you that this is the implication of this. When you have this thing you have here, this is what it implies, that x is greater than 3. Now, if x is greater than 3, x value is greater than 3, what do you think will happen to 3 minus x? Will 3 minus x be greater than 0 or less than 0? If x is greater than 3, will 3 minus x be greater than 0 or less than 0? Now, all you have to ask yourself is, what are values that are greater than 3? 4, 5, 6, and so on. All right? Those are x values that are greater than 3. If I impute any of these x values into this particular expression, 3 minus x, pick any of them, pick the least one, 3 minus 4. Is that less than 0 or greater than 0? Of course, that will be 3 minus x will be less than 0. Is that making sense? Are you able to flow with me? Do you get what I just said? Now, this was why I explained this thing earlier. Look at these two scenarios we are having here. I told you that when you have 3 minus x as the value from your absolute value, this was obviously a positive answer, which meant this was greater than 0, greater than or equals to 0. When you have this minus, this was obviously less than 0. So now, if you look at these two things here now, this will be our expression of interest, because from what this thing gave us, this brought us to 3 minus x being less than 0. So we are going to be using this for this. So we're going to be having this whole thing now will be minus 3 minus x over 3 minus x. I don't know if you can flow. We are flowing with that. Don't worry. I'm going to do a comeback quickly, and then I'm going to try and solve for the negative sign. side. If you look at what just happened here, what I'm doing right here, we are done with establishing. I started with talking about the absolute value. I said the absolute value can produce two results. Two results are possible here. This one, where we have a positive situation, and this one where we have a negative situation. Of course, when we have a positive situation, when you have a positive value, that means you're dealing with something greater than 0. When you have a negative situation, that means you're dealing with something less than 0. Now, we now came back to the instruction we were given. We're given that x was tending towards 3 plus, which I said implied x being greater than 3. Now, if x is greater than 3, when we have 3 minus x, and x was, look at this here, implies x being greater than 3. That means this 3 minus x in the absolute value, we would be dealing with x being greater than 3. If you fix greater values than 3 into 3 minus x, obviously this whole thing, this 3 minus x, will be less than 0. And whenever we have the less than 0, this was the case. This was the case we're dealing with. This was for the less than 0. So we'll be using this expression for our absolute value. So we'll be picking this expression for our absolute value now. And we'll be having this. So if you look at this now, this will produce an answer of -1. Now, there's something I'm going to do to help you guys. I'm going to try and solve for 3 minus. Let me try and solve for 3 minus now. So this is the answer of the question, by the way, -1. But let me try and solve for 3 minus, and let's see how we flow from there. So just stay tuned. Let's try and solve for 3 minus. Now, if I had x tending to 3 minus, let's say this was the limit I was given. Then, in that case, the implication of this will be less than 3. X being less than 3. All right? Now, let's say this was the same question. Let's say this was minus now. Let's say this was minus. Now, 3 minus x? If x is less than 3, what will happen to 3 minus x? Will it be greater than 0 or less than 0? That means I'm trying to find out which of these two will I be using. Will I be using this or this? Look at it now. 3 minus x. What are values that are less than 3? We have 2 is less than 3. We have 1 less than 3. We have 0 less than 3, and so on. Now, fixing 2, for instance, here. When you put in 3 minus 2, we have 1 as our result there. 3 minus 2 is 1. 1 is greater than 0. So that means 3 minus x here, from this expression, from x being less than 3, will always be greater than 0. All right? Will always be greater than 0. Now, in that case now, this is not our expression of interest. This will be our expression of interest. This 3 minus x. So where we have this our absolute value, we put in 3 minus x over 3 minus x. This, when we had 3 minus, we'll be producing an answer of 1. So that's conversely, if you have 3 plus, I already solved that one. We got an answer of -1. And if we have 3 minus, I got an answer of 1. Now, I would submit to you guys that we should just have a major class on calculus so that all these things we can get more deeper into it and solve more questions on it. All right. So this is just we doing corrections. So we have 2 other questions, very, very simple ones. That one I expect us to just do it orally. And the question, okay, there's one that talked about discontinuity. Let's talk about the aspect of the one that talked about discontinuity. So we can see that we're given a function. You know, you guys are meeting me with this question. So, and it's always best for us to establish the right basics. Some of you may probably be lacking with the basics. So it's not very easy to not know the basics and get into solving questions on it. All right, so we're given a function. Look at the function we're given. We're given the function x raised to power 4 minus 1 over x raised to power 2 minus 1. Now, please pay attention to this question. Let's see what's up. They said given this function, they said we should find a point of discontinuity of the function. So first of all, what is the point of discontinuity? What's the point? What's going to happen for you to say a function has gotten to that point of discontinuity? Now, the point where this is going to happen is when your denominator is equals to 0. So when the denominator is equals to 0, that will be a point of discontinuity. So now, at what point do you feel your denominator with this function you're dealing with, at what point do you feel this function will be discontinuous? What do you think will happen? What do you think will happen? What should be the value of x that will make this function discontinuous? Can you just try and over your mind around it? What's going to happen? What's going to be the values for x that will produce, the meaning of that discontinuity is just, at one point will x be, what should be x that will make the denominator equals to 0? What should be x? When it says plus or minus 1, when it says 1, yeah, obviously, the point where you're going to have your denominator to be 0 is where x is plus or minus 1, because if x is 1 here, that will be 1 square. 1 minus 1 will produce 0. If it's minus 1, of course, minus 1 square is still 1. So that means at x equals to plus or minus 1, this function will reach the point of discontinuity. So simple. How many of you got this in the test? Can you imagine the level of simplicity of this question? You're just supposed to identify what point are we going to have the denominator as 0, and that's all. That's actually the point of discontinuity. And the continuation of the question has said, and the new function if the point of discontinuity is removed. So if the point of discontinuity is removed, what's going to be the new function? So for us to get that, what you have to do is obviously just, of course, this is your function. You have x raised to the power 4 minus 1 over x squared minus 1. So you want to have, this will be x, of course, you remember this is difference of 2 square happening here, x plus 1 and x minus 1. Or we don't even need to express that denominator. We just need to express the numerator. Numerator also can be expressed. Numerator can also be expressed as difference of 2 square. What we have is x square minus 1 square. If you can understand what's going on here. So this is also a possibility under difference of 2 square. So this is the 4 square. So the final answer here will be x squared minus 1 and x squared plus 1, because these are the two squares now. You can see x squared and 1, they are the two values. So difference of 2 square is happening here also. So we're going to have the final answer as x squared minus 1 and x squared plus 1. So you can see this is, the numerator is x squared minus 1, x squared minus 1. So if you are removing, this is we trying to check if it is actually removable. And from what you can see, it's actually removable. That means the point of discontinuity is removable. That means we can eliminate the possibility of discontinuity happening. And if we want to eliminate the possibility of discontinuity happening, what we have to obviously just do is to make, is to cancel out these 2 points, these two, what we have here. So this will be, we cancel, since we can cancel, that means we're able to remove the point of discontinuity. So we will be left with x squared plus 1. So this will be the new function that we'll be getting if we remove the point of discontinuity. Now, the final question we have in this particular this thing, I want to exhaust this, is a question was written, and the question said, what's the relationship between A and B if the limit x tending to A of f of x gave you a, and the limit of x tending to a of f of x gave you b. I'm surprised anybody missed this question. So you're told to talk about the relationship between a and b. So you had a function. You subjected that function to this. The limit of, you were trying to get limit of x tending to a. You produced the result of a. You had the same function. You subjected it to x and then it produced b. And it asked you what's the relation between a and b. Of course, you don't need to argue this out. A is equals to b. That's the relationship. It's only a must be equals to b. There's no way a and b are not the same thing here, because it's the same limit is the same function. So a has to be equals to b. So it's just that very simple. All right. So I really believe at this point I have done justice to literally every question in this test. If there's anyone I didn't solve, possibly in the first class, was because I believe you could get the solution probably somewhere. I think I've solved it before. I think I didn't solve the question on coefficient of a binomial expansion, because I believe that question has been solved somewhere already. I believe that was the only question I didn't solve in all. So I've been able to, oh, I don't think I solved the y-intercept, did I? Oh, that would be probably later. You guys did not remind me. I did not solve the y-intercept. So we did not solve, or did we solve the y-intercept? Oh, I did. Okay, that's nice. Okay, I did. That's nice. Okay, so binomial expansion was the only one I didn't solve. You can get that on any of our other videos. So guys, this is where we're going to say a good night to each other. I believe from these 3 classes we held this weekend, I believe you should be able to have gotten something very tangible, and I believe you should be much more better in all of these subjects we dealt with. So please, I would love you to have good notes on all these classes, and ensure that you put in the best of the best so that we can get the results we are hoping for. So this is a beautiful good night to everybody. We'll keep pushing and seeing what, and hopefully this produces the best. All right, thank you very much. Enjoy your night.